Welcome to SV Union High School and Junior College.
Let's see another important component, that is diode. It is a PN junction diode. It is made up of a semiconductor in which we are going to use P type semiconductor and N type semiconductor. It is an important component in electronics for rectification and as a switch. Let's see diode. PN junction diode. A PN junction is a boundary or interface between two types of semiconductor, P type and N type. Inside a single crystal of semiconductor, it is created by doping. By adding P type semiconductor with N type semiconductor, we get a PN junction diode. Figure shows the electronic symbol of diode. The triangle shows the direction of current. The second diagram shows the construction of PN junction diode. Formation of depletion region or a layer. The excess electrons in the region crosses the junction and combine with the excess hole in P region. N region loses its electrons and becomes positively charged. P region accepts the electrons and become negatively charged. At one point, the migratory action is stopped. And additional electrons from the N region are repelled by the net negative charge of P region. Similarly, an additional holes from the P regions are repelled by the net positive charge of N region. Net result, a creation of a thin layer of each side of the junction which is depleted of mobile charge carriers. This region is known as depletion region or the depletion layer. The thickness of depletion region is in order of 10 raised to minus 6 meter. The depletion layer contains no free and mobile charge carriers but only fixed and immobile ions. The width of depletion region depends upon the doping level. Heavy dope having thin depletion layer and the lightly doped having thick depletion layer. PN junction can basically work into two modes. A battery is connected to diode is known as the biasing, and there are two types of biasing to PN junction diode. The first mode is forward bias. In this forward biasing, the positive terminal is connected to P region and negative terminal is connected to N region. Reverse bias mode, that is reverse biasing of diode. In this, negative terminal is connected to P region and the positive terminal is connected to N region. Forward biased PN junction. It forces the majority charge carriers to move across the junction. It decreases the width of depletion region. Hence, in a forward biasing of diode, the current flows through the junction. barrier potential. The electrons in N region have to climb the potential hill in order to reach the P region. Electrons trying to cross from N region to P region experience a retarding field of the battery and therefore repelled. Similarly, for holes from P region, potential thus produced are called potential barrier. The potential barrier for germanium is zero point 0.3 volt and for silicon it is zero point 0.7 volt. Reverse bias of PN junction diode. If the positive terminal of battery is connected to the N type and the negative terminal of battery is connected to P type, then the diode is connected is in reverse bias condition. The free electrons and free holes are attracted by towards the battery, hence back from the depletion layer, hence the depletion layer grows. Thus, reverse bias PN junction does not conduct current. So, in a reverse bias condition, there is no current flows through the junction. Thus, the PN junction diode allows the electrons flow only when P is positive. This property is used for the conversion of AC into DC, which is called rectification. So, the diode is used for the process of rectification. That's why it is also used as a rectifier. Figure shows the forward and reverse characteristics of diode. It is a graphical representation of the characteristics. In this graph, we have to draw the graph I versus V, that is current versus voltage. In forward characteristics of diode, for some time it acts as an insulator, so no current flows through the junction, and after some time the current starts flowing through the junction. So in forward bias we are getting current in the junction. In reverse bias condition, as there is a width of depletion region goes on increasing, no current flows through the junction, but practically a small leakage current flows through the junction as shown in the figure. Let's see the advantages of diode. As in diode, there is no filament is necessary. Second advantage is it occupies less space. Third advantage is it's having long life. Applications of diode. Diode is used as a rectifier. It is used to convert AC into DC. Diode is also used as a switch in computer circuits. Diode is used as a detectors in radios to detect audio signals. Diode as LED, it is used to emit different colors. Figure shows the connection diagram of forward bias and reverse bias. In forward bias, the positive terminal of diode is connected to the positive terminal of battery and the negative terminal of diode is connected to the negative terminal of battery. While in reverse bias condition, the positive terminal of diode is connected to the negative terminal of battery and the negative terminal of diode is connected to the positive terminal of battery. The main application of diode is it is used as a switch. When we connect diode in forward bias condition, the anode of diode is connected to the positive terminal of battery and the cathode of the diode is connected to the negative terminal of battery. So the diode becomes forward bias. As the diode becomes forward bias, the current flows through the junction. Hence, in forward bias condition, the diode works as a closed switch. In reverse bias condition, the anode is connected to the negative terminal of battery and the cathode is connected to the positive terminal of battery. Hence, no current flows through the junction in reverse bias condition. Hence, in reverse bias condition, the diode works as a open switch. Figure shows the symbolic representation of diode. On diode, there is one ring is printed and that ring indicates the negative terminal of diode. As in symbol, there is one triangle and one vertical line is given. That vertical line indicates the negative terminal of diode and on the diode there is one ring is printed that indicates the negative terminal of diode. Hence, the diode having two terminals, positive and negative, anode and cathode. So, this is all about diodes. In this video, we studied about the forward and reverse characteristics of diode. Thank you. Thanks for watching.